Alright, welcome. We're going to talk about our next lesson, which is on solving systems by the elimination method. Alright, now getting into this, there are 4 steps that we're going to do. The first step is we are going to write the system so that like terms are aligned vertically. So the x term from one equation is matched up with the x term from the other, same with the y term and any constant terms. Step 2 is we are going to eliminate one of the variables and solve for the other variable. Once we've done that, we can go on to step 3, which is to substitute the value of the variable into one of the original equations and solve for the other variable. Once we've done that, we can move into the last step, step 4, where we're going to write the answer from steps 2 and 3 as an ordered pair. Remember, ordered pairs have an x term and a y term. And I'm not going to worry about you doing this one as much, but some people like to then check by putting both x and y into both of the original equations and making sure it works out. So let's actually look at our first example, which I think we might have to go on to a new page so we have enough space. So our first example, we'll call it example 1. We're going to solve x minus 2y equals negative 19. And 5x plus 2y equals 1. Now, step 1 is kind of already done for us, but let's rewrite it, where we have x minus 2y, 5x plus 2y. In fact, I'm going to adjust this just a little bit. I'm going to go x, and right beneath it, 5x, minus 2y, plus 2y, equals negative 19, equals 1. Now, using the elimination method, here what we can do is we can add vertically. We're going to add these two systems together, going vertical. So we're going to add the two x terms, x plus 5x, that makes 6x. So we're actually into step 2 right now by solving, by eliminating. Because now if we go negative 2y plus positive 2y, that's going to give us a 0y, which is just going to be 0. Negative 19 plus 1 makes negative 18. And really, this just simplifies to 6x equals negative 18. And we still want to solve this for x because that's part of step 2. So we divide by 6. We're going to find that x equals negative 3. So we've completed step 1 and 2. Step 3, we're going to go to one of the original equations and plug the number we just got in step 2 and solve for the other variable. So I'm actually going to pick the top one. You could totally pick the second equation and it'll give you the same answer. So I'm going to go negative 3 minus 2y equals negative 19. I'm going to add 3 because I'm trying to solve for y. So I'm going to have negative 2y equals, well, negative 19 plus 3, that's negative 16. Then I need to divide by negative 2 because I'm multiplying the y by negative 2. So to undo it, we use division. We're going to find that y is equal to, in fact, I did not need to write that y right there. Negative 16 divided by negative 2 gives me a positive 8. So I can now move into step 4. I write my answer as an ordered pair. I have an x value I found in step 2 and a y value from step 3. So my solution is going to be the ordered pair negative 3, comma 8. We finished example 1. Let's look at one more example, and then we can probably wrap up this video. So we'll call this one example 2. We're going to solve 3x plus 4y equals 18. And negative 2x plus 4y equals 8. So I did not mention this earlier. Part of why we use this elimination method is if the number in front of one of the variables in both equations is the same, the elimination method is going to be a great way to do it. Our main goal is to have them be the same number but opposites. So we want one to be positive, one to be negative. In our last example, that happened with the y terms. We had a negative 2y and a positive 2y. In this example, I see that my y terms have the same coefficient. They're both 4. So when I am doing step 1, rewriting everything, to be vertically aligned, what we're going to want to do is we're going to want to make one of those 4's be opposite. And really it's just easier to make the entire second equation be opposite. So that means multiply everything by negative 1. So we can rewrite this as 3x with a 2x below it plus 4y, and below that we have a minus 4y equals 18 and equals negative 8. And then this looks more like what we just did in our last example. Now vertically adding 3x and 2x, we're going to get 5x, and our y terms are going to cancel each other out. So I'm not going to actually write anything under the y terms. So 5x equals, well, 18 minus 8, that is 10. We want to solve for x, so we'll divide by 5. 10 divided by 5 is 2, so we found x equals 2. And that was steps 1 and 2. Now we're going to move on to step 3, where we are going to take that 2 and put it into one of the original equations and solve for y. And I'm going to just pick the top one. It doesn't really matter which one you use. So I'm going to go 3 times 2 plus 4y equals 18. Well, 3 times 2, that's 6. So 6 plus 4y equals 18. So I'm solving for y, so I need to subtract 6, get that to the other side. I have 4y equals 18 minus 6 is 12. Then I need to divide by 4. So we're going to find y equals 12 divided by 4, that is 3. So step 4, we write as an ordered pair our solution. We found an x in step 2, which was 2, and in step 3 we found a y to be 3. We've got our solution. That is going to wrap up this first video, which will be 2 parts for solving systems using this elimination method. So stay tuned for part 2.